followed by an equation. So we are looking at launching an object. Okay. Before, right? So what we're trying to find out is the height from the highest point to the height from which it is shown. So it will be here. We're trying to determine this height over here. Okay? So when it is being shown up, this is where time is equals to 0. Okay, so we can determine what is the height of this first. Okay, so when t is equals to 0, we find that h is equals to 10 because your variables become 0. Okay, so we see that this will be a value of 10 meters. Right? Then we want to determine what is the maximum point. Okay, because this is a maximum curve. Right? We can determine it by knowing what is the coordinates of the turning point, and that will be done by looking at the completed square form. Okay, so your completed square form, in your quadratic equation over here, we have a negative t squared. What must we do first? What must we do first? Just factorize out the negative, right? Okay, we get negative bracket t squared minus 5t minus 10. And then we do our completing the square. We get this. Then we'll continue here. We have t squared, sorry, not t squared, but t minus 5 over 2 bracket square minus away, what's the value? 25 over 4 and 10. Negative 16.25. Okay, we get this. Right? Any problems in the completing the square? Okay, so now to know what is the maximum height from the ground itself, okay, that will actually be 16.25 because we know that the lowest that the square can go is 0. Okay, otherwise it will only be a positive value, that means any number that's higher than 0. Okay, if it is going to be any higher than 0, we will be deducting away, because there's a minus sign from here, deducting something away from 16.25. So any value of h will actually end up becoming lesser than 16.25. Okay, so therefore our maximum h value is 16.25 meters, but this is away from the ground. Okay, we want to determine this difference over here. And that will be 16.25 minus away 10. Okay. Does it clear up for those who ask this question? Alright. Then question 7. Question 7, may I clarify, is an issue in terms of forming the equation. Is it about forming or the entire thing? Okay. Okay, let's read the question now. Okay, I'm not sure how many of you brought your E-Maths textbook, but we are on page 34. Okay, it says that anything travels 700 kilometers by coach from Singapore to Penang to visit her grandparents. So I like to draw a diagram. We're looking at Singapore to Penang. Okay, and this distance is 700 kilometers. She returns to Singapore by car. So that means from Penang to Singapore. Okay, at an average speed which is 30 kilometers per hour greater than that of the coach. So over here it is by coach. Okay, for which we do not know what is the speed. We let it be X kilometers per hour. No. Because question defining later on that the average speed of the car is X kilometers per hour. Okay, so this average speed is 30 kilometers per hour greater than this one. That means down here is slower. This will be X minus 30. Okay, are we able to see these two variables first? Can you understand the question at this point? Then it continues to say that the time taken for the whole journey is 20 hours. Okay, total time taken is 20 hours. We want to formulate an equation in X and show that it reduces to a certain equation. Okay, so that is our objective. Right? So what we are told is this total time taken is 20 hours. Okay? We are given information about the speed. We are also given information about the distance. So how to actually rely on this information over here? We need to be familiar with our distance speed time. Okay? So time is derived by taking distance divided by speed. So we know the distance for the journey from Singapore to Penang is 700 kilometers. So the time taken, okay, from Singapore to Penang will be 700 divided by X minus 30. Okay, so time taken distance divided by speed. So we get 700 over X minus 30. Okay, very often when we craft our own expression, we tend to forget the units. Okay, we want to actually put in the units to remind ourselves that this is in hours. How do I know that it is in hours? It is because the units over here is kilometers per hour. This one is in kilometer. So the time must be in hours. Okay. Then our time taken in the reverse direction will actually be 700 divided by X. Okay. So we need to know the respective time taken first. Then now we know that the total time, which is the sum of both of it, okay, will be equals to 20 hours. Right? So adding them up will get you 20. And this is a reminder for ourselves that the total time taken is expressed in hours as well. So we need not do any unit conversion. Unlike the question that we saw on SLS for home-based learning, okay, our expression was in hours, but we're given in minutes or something like that. I don't quite remember. Okay, but we need to be careful about the units. Right, then from there, it will be about simplifying the equation to meet what the question wants. So we will combine the fraction to the same denominator. Okay, the denominator we choose is x times x minus 30. Following that, we can cross multiply. At the same time, I'm going to expand the numerator as well. Okay, we get 1400, okay, 1400. Right? Then we simplify it. I'll just keep my coefficient x squared positive. Okay, and we notice that we can factorize out of 20. 2,100 divided by 1050, right? 1,050. Okay. Yes. So we arrive at this, then we can divide the 20 over and conclude. That we are able to show the quadratic equation. Okay. I would assume that part 2 is solvable. We use our quadratic formula, okay, to solve, and then we can get the value in x. A reminder that we're supposed to leave our answer to 2 decimal places. Okay, so do make a check, then you know what is 2 decimal places. Okay. Then part 3, to find the time taken for the return journey. Since we already found x, okay, I assume one of the solution is negative. See? What's the solution that you get? One of it is negative. Okay. Yeah, so we reject that one. We only use the positive value. Substitute into this expression for the x. Then we will find out what is the time taken from Penang to SG, which is the return journey. Okay. Questions? Okay. Yeah. Next, question 8. Question 8, may I know what is the issue? Is it part 1, part 2, part 3? 3, huh? Part 1 and 2 can? Okay, wait. Okay. Some say wait.
I'm copying.
Okay. Then, like that can? I erase the center can? Yeah. Okay, a tank contains 1,500 liters of water. Pump A can fill the tank with water at a rate of x liters per minute. Pump B can fill water at a rate of x plus 50 liters. Okay, so in question A, just to give you the gist of the question, it says that there's a water tank. It can fill 1,500 liters. If we fill up using pump A, we can do it in x liters per minute. If you're doing it using pump B, it can fill up using a rate of x plus 50 liters per minute. So in part I, to determine the number of minutes it takes for pump A to fill the tank completely, okay, we will take 1,500 divided by x. Sorry, minutes. And then for part 2, we will be able to do so in 1,500 divided by x plus 50 minutes. Okay, part 3. It says that pump A takes 30 seconds longer than pump B to fill the tank completely. So we need to be able to decipher this statement. Information given in this question. about the units.
30 seconds.
We must notice that this is in 30 seconds. And what is it that we have over here? It is in minutes. So we need to be cautious about that. I'm not sure whether you form equation, did you do the unit conversion or not? That might be one reason why you're not getting the equation. Okay? Then pump A takes 30 seconds longer, okay, than pump B. So that means pump A, the value itself, this one is A, and this one is B. This value is a bigger number than this value. Agree?
Yes.
Okay, because it takes longer, the duration is longer. So you can understand this statement as A minus B is 30 seconds longer. The difference itself is 30 seconds longer. That's how you could interpret the question. Okay, so A is 1500 over X minus away B, and keeping in mind about the difference in units, our 30 seconds is to be converted into minutes, so that will be 30 over 60. Okay? Alright, then the rest of it is about simplifying, okay, the fractions. So we get 1500 times x plus 50 minus 1500x. 30 over 60 is half. Okay, then we calculate. 5 times 1500, 30, 60, 75. Will be 1500 over 363.10 plus 50. In fact, I would prefer if you take a higher accuracy rather than the final answer of part 4. That would be okay. Usually I will take one more digit, okay, minute and 0.6310 times 60. Convert it into seconds. And that will give us about 37 seconds, 38 seconds. And round up. You have that, Aris? So you just 63. Okay, so it's common that people just see the decimal here and then take this as seconds. So we must remember, okay, that for minute to second conversion we must have 16. Okay, in fact it shouldn't make sense to you that end up 63 seconds because 63 seconds is more than 60. That will form another minute already. Right? Then why isn't our answer 4 minutes something? Okay, so sometimes when we get an answer, for some logical thinking behind it, does it make sense? Okay, yet after you write 3 minutes and 63 seconds, end up you get 4 minutes. Technically over here you should have rewritten the 4. Okay, so that shouldn't have happened. Right? Any other questions regarding question 8? Okay, how about question 11? You said part 3, right? Okay, let me read the question. Given the flight of the balloon above ground level, determining model by this. State the value of t. Okay. So in our question 11, we have a graph being given, right? Okay. And the graph looks something like that, if I recall correctly. Is it something like that?
Yes.
Right, the shape. Okay. So this graph is for the equation. This one. In part 3, it says that given the flight of the balloon above ground level can only be modeled by this equation, okay, for 0 to t. We want to state the value of t. Okay, first of all, let's understand what the question is trying to say. What do we mean by using an equation to model after something? Okay, to say that we use an equation to model after something is to say that we are using this to represent the path. But how does this entire equation actually look like if you were to plot it out, okay, the entire thing, or if you use a computer program? Our graph actually is endless, okay? It goes on infinity like that. Wow. Right? Okay, this is how reality speaking, okay, the graph should look like. It goes on forever. Okay? But the question says that the path of the balloon can be modeled by this equation for this interval. Okay, this is what this phrase actually means. Okay, we are using only part of the graph. Okay, and which part are we referring to? We're only referring to when x is between 0 to t. So if you think about it, okay, can the balloon fly, okay, and then after that go underground? Yes, I don't know why you leave, okay, but it doesn't make sense. Okay, the flight of the balloon, alright, should at most reach, okay, the ground level only. Okay, your balloon don't fall onto the floor and then after that start to force its way through into the ground, right? Correct? Okay, if you tell me yes, I think we need a lesson on forces for your physics, okay, and I'll tell you all about that. Right, so it doesn't go sink into the ground. Right, so it stops somewhere. Where does it stop? It stops at the ground level. And where is the ground level? It is when your height, okay, is given to be, sorry, this one is a y, right? Okay, your y, which is the height itself, okay, stops here. So the t value that you need to arrive at, okay, from reading the graph, it is this value that you read from the graph itself. You understand? Okay, so it's just reading and telling me what is this value. I'll leave it to you to read. Okay? Okay, so to explain, you can say that the height of the balloon cannot go into negative. Okay? So y must be positive, and it is only positive between 0 to that value that you need. Alright? If you're okay, can you submit your homework? Did everyone receive back your homework? Okay, I want to talk about certain things regarding your homework. This is my marking key. So if you see such word, this is what it means. Okay? If you see a key, it means presentation. Okay? A common presentation problem that many of you have is in terms of the equal sign. Okay, so I will usually give a remark, okay, for the first of such presentation error. Okay, so what kind of equal sign am I talking about? For example, question 3a. I have people, don't pay attention to what I write in class. Okay, this is all expression. Okay, when you're trying to complete the square or simplify whatever, okay, please make sure you have your equal sign. So I would have indicated only like that. Okay, so that is a problem, right? You need to write that. But in contrast to maybe question 5b, okay, for example, in question 5b, it's not a complete answer. This is an equation that we're trying to solve. There should not be any equal sign over here. Okay? Down here, no equal sign required. Alright, the equal sign is actually all found in the middle. Okay? So this is the correct presentation. Alright? Next, A, which is another common problem that represents accuracy. I'm not trying to grade your work, I'm not telling you that your work is great, okay, but indicating a A. A means accuracy. So for example, the standard expectation, okay, when a question doesn't state what is the level of accuracy, we always need to treat as F. Okay, we need to treat as F for non-exact answers. But in some of your questions, okay, for your homework, some of them ask for it to be in 2 decimal places or 1 decimal place. For example, question 5D. Okay, for question 5D is one such example. The question wants it to be in 2 decimal places, not 3 significant figures. So some of you habitually write in 3 as F. Okay, so do be mindful about that. It should be 2 decimal place. And then for question 8 part 2, it should be 1 decimal place. Sorry, not 8 part 2, 6 part 2, sorry. Your answer should be 1.6 or negative 18.6 because the question asks for 1 decimal place. And for 7b, your answer should be 0.209 or 4.79 because the question didn't specify, so we leave answer to 3 significant figures. I do have 1 or 2 of you who think that 3 significant figures is 0.20. Okay? When it comes to a decimal, this first 0 is not counted as significant. We start counting significant figures from the first non-zero digit. Okay, so in this case, it should be 0.2093 SF. Okay? Right? Then, other things, okay, B represent brackets. Okay, some of you have missing brackets. And then, in general, U for units. Okay. R for reason. I have not yet used all this. Okay. And S for simplify. Okay. So these things have not yet been seen in this piece of homework. Okay. Then another feedback that I want to give for question 5D and for question 7B. I'm not sure why there are a number of you who gave it to me to solve the question by using quadratic formula. Okay, this exercise is meant to be completing the square, so I expect completed square form. Alright, so if you did it via that, please do your correction. Okay, do it via completed square form. Alright, then in question 6, part 2, in your textbook, the question says hence solve the equation. So you must use the completed square form. Okay, you must use completed square form that you did in part I. Okay, even in the exam, that is how we usually word the question as well. If you did not use the completed square form, you do not get the mark at all. Okay, even if your final answer is the correct one. Okay, so I want to emphasize on that. Okay. Are there any other questions? Okay, in your homework, you will notice that at the front page, there may be a very big C on top. C means correction. Okay, so you must do your correction. For which question, I will usually circle the questions that you need to pay attention to. Okay, so unless I mark too fast and then I forget to circle, but you should take a look at all my marking. Okay. Yes, next. Sorry, C stands for correction, so you use a green pen to do your corrections. Okay, so down here is all your working. If I mark it wrong, do your corrections here beside it. Just do that particular question. I think it's about your mindset of excellence. Should you do the whole thing or should you continue from where? Yeah, okay. Okay, any questions? Right, so once you're done with corrections, you can just file inside your file, which is already behind at the back of the classroom. Okay, I will do the file check and the corrections check when I collect the file. Okay?
Wait.
Huh?
Wait.
What?
Salam.
Because in the classroom easier, ma. Yeah, I want later all of y'all got bring, don't never bring. I just conveniently put it behind the classroom for you. Okay? Some of you, not all your classmates have good habits of putting the things neatly in class. So I just want everything compiled nicely at the back. Okay? Okay, now what time is it?